So in this section, we're going to talk about several new identities and formulas that we can use to simplify trigonometric expressions. We're going to talk about the double angle formula, the half angle formulas, and the power reducing formulas. Actually, not in that order. The first thing we're going to discuss is the double angle formulas. Now, I do need you to know these double angle formulas. On the other hand, they're very easy to prove, but you'll notice right here at the top of the page, you have five double angle formulas. The first one, sine of 2 theta equals 2 times sine of theta times cosine of theta. So if you have twice an angle in here, you can break that down to 2 just sine of that angle, not twice the angle, just the angle times the cosine of just the angle. And then there are formulas for cosine of 2 theta and tangent of 2 theta. So on the following pages, what we plan to do is prove all of these. And the proofs are very simple using identities that we have already learned. So the first proof I want to take a look at is I want to prove that sine of 2 theta is equal to 2 times the sine of theta times the cosine of theta. So what we're going to do is we're going to start with the left-hand side, okay? And that, of course, is sine of 2 theta. And what I want to do is use an identity that we already know to prove that that is 2 sine of theta cosine of theta. And a way to think about this is that sine of 2 theta is equivalent to sine of theta plus theta. Now, why would I do that? Well, first of all, you know theta plus theta is 2 theta. But we can use our addition and subtraction or your sum difference formulas for sine in this case, or for cosine or for tangent to prove the other ones. So you're called, can you remember the formula for sine of alpha plus beta? Well, our alpha is theta and our beta is also theta. So to use the sum difference formula, we're going to say this is sine of theta. And you remember the sine alternates, so times cosine of theta. And you keep the common sign, which is addition. So that's going to be cosine of theta times sine of theta. So if you need to look up the sum formula for sine, go ahead and look it up. Again, it is sine of alpha plus beta is sine of alpha cosine of beta plus cosine of alpha sine of beta. And that's what we've done. So we're going to put that we use the sum difference formulas. Okay. Here we just rewrote, and I should say rewrite 2 theta as theta plus theta. That's probably even more detail than you would have to give me, but that's what really happened. Okay. Now check this out. These are like terms. I've got sine of theta times cosine of theta plus cosine of theta times sine of theta. Well, they're exactly the same thing. Remember, you could use the commutative property of multiplication to switch this around. So that's 2 of them. So that's 2 sine of theta cosine of theta. And that's the end of our proof. We have proven what we needed to prove. So what would I write for an explanation? We just added like terms. Okay? So pretty easy proof. You just have to know the sum difference formulas to pull this off. So next we want to prove that cosine of 2 theta is equal to cosine squared of theta minus sine squared of theta. Notice this formula looks completely different than the sine of 2 theta formula. But let's show why, and then you'll realize, oh, okay, well that makes sense. So we have the left-hand side is equal to the cosine of 2 theta. So just like I'm verifying an identity, well, the cosine of 2 theta, I can rewrite as the cosine of theta plus theta. So again, all I'm doing is rewriting 2 theta. Okay. Well, now I need the formula for cosine of alpha plus beta, or cosine of 2 angles added together. So remember, that formula is cosine of the first angle, or alpha, which is theta in our case, times the cosine of the second angle, beta, which is theta, also in our case. Then the sign changes, minus sine of the first angle sine of the second angle. And again, the first and the second angle is theta in our case. So again, what do we do here? We use the sum difference formulas for cosine. Well, now I can multiply. Cosine of theta times cosine of the same angle theta is cosine squared of theta. Minus, same story here, sine squared of theta. What did you do there? Well, I just multiplied. Okay? End of proof. We're there. Okay? Now, that's not the only formula you can use for cosine of 2 theta. You can also rewrite that as down here below, cosine of 2 theta is 1 minus 2 sine squared of theta. Can you see how we can get from the line we just created to that? Okay, so again, I'm going to start with cosine squared of theta minus sine squared of theta. How can I make that equal to 1 minus 2 sine squared of theta? That's the question. Okay, well, pretty easily, right? If you recall, cosine squared of theta is 1 minus sine squared of theta. Remember what that identity is called? How about Pythagorean? That's one of our 9 different versions of the Pythagorean identity. Okay, now I'm going to combine like terms. So I've got 2 different negative sine squared of thetas, so that's 1 minus 2 sine squared of theta. In a proof, all I did on that line was combine like terms. Not only that, there's another way to write. There are 3 different ways to write cosine of 2 theta, so all of those ways are included. Let's start where we left off here. Again, cosine squared of theta minus sine squared of theta. Now, how can I easily convert that into 2 cosine squared of theta? Well, it looks to me like they got rid of the sine squared. Well, what is sine squared equivalent to? Well, I've got cosine squared of theta minus, how about 1 minus cosine squared of theta? Once again, I'm using the Pythagorean identity, one of those 9 different versions. So that would be cosine squared of theta minus 1 plus cosine squared of theta, right? I'm distributing that minus sign inside. I'm going to add like terms. So that gives me 2 cosine squared of theta minus 1. And we have proven the 3rd version of cosine of 2 theta. Alright, so we have one more of these double angle formulas to prove before we can have an opportunity to use them. I'm going to start with the left-hand side, which is tangent of 2 theta. The principle that we've used for the other 2 is going to be the same here. I want to rewrite that as tangent of theta plus theta. Okay, so I'm rewrite 2 theta. And that's so I can use the sum difference formula. I'm going to use it for tangent this time. So if you'll recall, tangent of alpha plus beta is tangent of the first angle plus tangent of the second angle. It almost feels like a distributive property. It's absolutely not that, because it's not multiplication. And then you do 1 and you change the sign, tangent of theta times tangent of theta. Okay, and again, this is just the sum difference formula. This, of course, is the sum for tangent. Now I've got like terms in the numerator, so that's going to be 2 tangent of theta over 1 minus tangent of theta times tangent of theta is tangent squared of theta, and bingo, there we go. We've got our identity. Okay, so these are 3, really 5 very simple proofs to do, so don't feel bad saying you need to memorize these, because really you need to be able to just prove them. You don't even have to memorize them. I didn't write an explanation for the last line. We added like terms, and in the denominator we just simplified. If you just told me like terms, I'd be okay with that. Okay? So our first examples that we're trying to do is use the figures to find the exact values of each of the trigonometric functions. Notice we have a figure for theta, okay, and we have a triangle or a figure for alpha. So when you do these problems, make sure you're looking at the right figure for your particular problem. So first I have sine of 2 alpha. Well, notice I don't have a picture for 2 alpha. I need to use the formula for 2 alpha. So you may remember the formula. I could always go back and show you right here, okay? Sine of 2 theta is 2 sine of theta times cosine of theta. So when we go back to our problem, I'm going to rewrite the sine of 2 alpha using my formula is 2 sine of alpha cosine of alpha. And then I'm going to use my figure to actually calculate the sine of alpha and the cosine of alpha. So look at your alpha triangle. Okay, so that's the second one over here. And I'm going to have 2. Now the sine of alpha, remember the sine is opposite over hypotenuse. Well, guess what, folks? We don't have the hypotenuse, so we're going to find that before we can finish our problem. So we have 24 squared plus 7 squared is equal to the hypotenuse. I'm going to call it c squared. So that gives me 576 plus 49 is equal to c squared. And 576 plus 49 is 625 is equal to c squared. And the square root of 625 means c is equal to 25. Okay, so the hypotenuse over here is 25, and that's a perfect triple. You might have recognized that right off the bat, and that's great if you did. So sine, remember, is opposite over hypotenuse, so I have 7 over 25, and then the cosine is adjacent over hypotenuse, so that's times 24 over 25. Now any of these fractions that you can reduce, you go right ahead. In this case, notice nothing reduces. 25 and 24 and 7 and 2 don't have any common factors. So now I'm charged with just multiplying this all together. So I have 2 times 7 times 24. That gives me 336 over, and then 25 times 25 gives me 625. And again, I know that won't reduce because it wouldn't reduce before. So let's try the same thing dealing with tangent of 2. Now notice this is theta this time. This is not alpha, so I'm not dealing with my second triangle at all, only the first triangle. And I need to write down the formula. Again, if you need to look at the formula, tangent of 2 theta, right here. Okay, so I'm dealing with 2 tangent of theta over 1 minus tangent squared of theta. So I'll write my formula down, 2 tangent of theta over 1 minus tangent squared of theta. So I have 2. Now tangent of theta, look at the correct triangle. Remember, tangent is opposite over adjacent. So it's 3/4. Okay. Divided by, I don't need that extra set of parentheses, by the way, 1 minus, and again, tangent squared of theta, so that would be 3/4 squared. Now you just need to simplify this. Now I do notice this 2 and this 4 is going to leave a 2, so that gives me 3/2 in the numerator. You see that, right? Over 1 minus, now I need to square this first, order of operations, so it's going to be 9/16. I need to combine this fraction together before I'm allowed to invert and multiply. So that means I really need to multiply this 1 by 16 over 16. Okay, so that's going to give me 3/2 still remaining in the numerator. 16 over 16 minus 9 over 16, which gives me 3/2 divided by 16 minus 9 is 7 over 16. Now it's time to invert, so that's 3/2 times, I flip it, 16 over 7. Continue down here to simplify. This 2 and the 16 will cancel, which gives me 24/7, and that is lowest terms. Always make sure your fractions are in lowest terms. Okay, so for this problem, let's just use the given information to find the exact values of each of the trigonometric functions. I'm really just trying to find the cosine of 2 theta. Notice I don't have a picture or a diagram drawn here, but I can draw that given this information. Notice it says theta is in quadrant 2, which is telling me I need an xy axis, and I also need a line drawn in quadrant 2. Okay, so my theta is here, but my reference angle I can just draw inside. Okay, I need to label the sides. Remember, cosine is x over r, or you can think about it as adjacent over hypotenuse, and the hypotenuse is 3. It cannot be negative. That means the adjacent side must be the -2. Not only that, in quadrant 2, your x values are negative. Now we probably need to find this missing side. We always do, right? We just don't always use it. So I've got side squared plus the missing side here squared. I'm going to call it y equals 3 squared. So I have 4 plus y squared is equal to 9. I subtract my 4. It gives me y squared equals to 5, which gives me y is plus or minus the square root of 5. But in my picture, that is a positive square root of 5 because we're talking about in quadrant 2, or above the x-axis. Now I use my formula, and then you might be thinking, wait a minute, I have 3 formulas for this. Which one do I use? It doesn't matter as long as you have the appropriate information. So let's go back and look, okay? You've got cosine of 2 theta. I'm going to highlight this in purple for you, or pink. Cosine of 2 theta is cosine squared of theta minus sine squared of theta. Or it is 2 cosine squared of theta minus 1, or it is 1 minus 2 sine squared of theta. Either of those, any of the 3 will work. The easiest actually would have been this one right here when we didn't have that missing side because we already had cosine. But let's just use this one. As a matter of fact, we could use both of them if you want, or all 3 of them, and see if we get the same answer, which we should. Okay, so we've got cosine squared of theta minus sine squared of theta. So I go back to my problem and say, okay, we're going to use cosine squared of theta minus sine squared of theta. Okay, so cosine, we already know, is -2/3, and then we square it. Minus sine squared, well, sine, remember, is opposite over hypotenuse, so that'll be the square root of 5 over 3. Again, you've got to square it. Why are we squaring it? Because of the squares, okay? So that gives me 4/9 minus 5, the square root of 5 squared is 5/9, and then 4/9 minus 5/9 is -1/9. So we're done with this problem. But just in case you're not convinced that that's correct, let's talk about another. So we're going to try the 2 cosine squared minus 1. All right, so I'll go back over here. In blue, I'm going to do 2 cosine squared of theta minus 1. So that's going to give me 2, and then cosine squared is going to be -2/3. Don't forget to square it, minus 1. That's going to be 2 times 4/9 minus 1, which gives me 8/9 minus 1. I need a common denominator, right? So I'm going to multiply this guy by 2. No, I'm not. How about by 9/9? Okay, so it's going to give me 8/9 minus 9/9, surprise, -1/9. Any of those 3 formulas will work. Whatever works best for you is the best way to go. All right, so here I have another problem for you that asks us to find the exact value. This time it's sine of 2 theta. Now, unlike the last problem, there's only one formula for sine of 2 theta. Maybe you know it already. It's 2 sine of theta times cosine of theta. Now, don't fret. If you can't remember what it is, it's super easy to prove. Just write that as sine of theta plus theta, and you have to know your sum difference formulas. You might not know it while you're watching this video, but y'all, you have to learn those sum difference formulas. So we're going to use this formula, but we have to draw a picture to represent what we have going on here. So here's my xy axis. It tells me right off the bat, theta's in quadrant 4. So I'm going to draw a line in quadrant 4. Always go back to the x-axis to get your reference angle inside here. That's theta. I'm going to label my sides. Remember, tangent is opposite over adjacent, if you like that. So -3/1. You got to make it a fraction. So opposite over adjacent. Or you can use your definition. That's y over x. Either way, this guy right here is -3, and this guy right here is +1. You agree? The negative had to go with the y value, because this is a positive x value in quadrant 4 and a negative y value in quadrant 4. Now, sine and cosine, back over here, what we're going to have to get from our triangle, does use the hypotenuse, so I do have to find this missing side. So here I go, Pythagorean Theorem. So 1 squared plus negative 3 squared is equal to the hypotenuse, or c squared. So I have 1 plus 9 is equal to c squared. That means 10 is equal to c squared. So y'all, what's c? Square root of 10, right? Alright, so this guy right here is the square root of 10. Is it positive or negative? Well, it's positive, right? The hypotenuse, or the r when you're talking about the unit circle, is always positive. Always. Even though when you solve this equation you get positive and negative, but that's always a positive because you're talking about the length of that line. Alright, now, I've got all my triangle filled out, right? So I come over here and I plug into 2 sine of theta cosine of theta. So that's 2. Sine, remember, is opposite, which is negative 3, over hypotenuse, which is the square root of 10. Or you might have that it's y over r. Either way, it's negative 3 over the square root of 10. Cosine is adjacent, which is 1, over the hypotenuse, which is square root of 10. Or you might have it memorized that it's x over r. And that will still get you 1 over the square root of 10. Now we multiply. When you multiply fractions, remember you multiply numerator times numerator times numerator, which is going to give me negative 6. And then denominator, which is 1 times square root of 10 times square root of 10. And y'all know the square root of 10 times square root of 10 is square root of 100, which is 10. Or you can think about it as the square root of 10 squared, which is still 10. Don't leave it like this. I will take a point or more. You need to reduce that to lowest terms. 2 divides into both of those, so negative 3 fifths. That is a 5. I'm hating on that 5. So how about negative 3 fifths is your final answer. So that is sine of 2 theta. Not my picture. I don't have 2 theta drawn. I just have theta drawn. But sine of 2 theta is negative 3 fifths. Okay, let's do one more of these problems before we close down this part of the video. So I've got cosecant of theta is negative 5, so we'll have to remember how is cosecant defined. If you have your x's and y's and r's memorized, remember cosecant is the reciprocal of sine, so that must be r over y, okay? Or hypotenuse over opposite. Because again, cosecant is the reciprocal of sine. Sine is opposite over hypotenuse, so I flip it. It's hypotenuse over opposite. Okay? And we're in quadrant 3. So I'm going to draw my xy axis. I'm going to draw an angle with a terminal side in quadrant 3. My reference angle is this guy right here. So you're talking theta is going to be right there. My r value is 5. Is it 5 or negative 5? Well, r can't be negative, right? So that's 5. Then what in the world's negative? Well, the 1 must be. Remember, if I write this as a fraction, it's negative 5 over 1. But the negative has to go with the 1 because it sure doesn't go with the 5. R is never negative, so this is negative 1. We got to find our missing side over here. So I have negative 1 squared plus y squared equals to r squared or c squared, whatever you want to use. That's 1 plus y squared is equal to, how about we use a 5 instead of an r? We'll try it again. Fixed. Okay, so that's 25. I subtract the 1, that gives me y squared is equal to 24. I take the square root of that, so y is equal to plus or minus the square root of 24. Don't leave it like that. That's plus or minus. Square root of 4 times the square root of 6 is 2 square root of 6, right? Is it positive or negative? Real fast, look at your picture. That's negative 2 square root of 6. Y values are negative in quadrant 3 because we're below the x-axis. Okay, so we have all of our sides. We got a negative 1, we got a 5, and a negative 2 square root of 6. Now we're going to use our formula to find tangent of 2 theta. You could go look it up. I'll help you with that. Or you can just have it memorized. So it's our aqua one right here. Tangent of 2 theta is 2 tangent of theta over 1 minus tangent squared of theta. So if I go back to my problem, I suggest always writing your formula down. So it's 2 tangent of theta over 1 minus tangent squared of theta. So it's going to give me 2 times. Now tangent. What is tangent? Tangent is y over x, which is negative 2 square root of 6 over negative 1, or opposite over adjacent, same thing. So negative 2 square root of 6 over negative 1 in parentheses, because we're multiplying it times 2, over 1 minus, and then it's still tangent of theta, but it's squared. So it's negative 2 square root of 6 over negative 1 squared. So now we want to simplify this expression. So the two negatives are definitely going to cancel. And I'm going to have 2 times the square root of 6, which is going to give me 4 square root of 6. And the denominator, I'm going to square the negative 2 and the square root of 6. And then, remember, the two negatives cancel there as well. And that's over 1. So that's just going to be 1. And again, remember, those are gone. So this is still minus. 2 squared is 4. The square root of 6 squared is 6. So that gives me 4 square root of 6 in the numerator, and then 1 minus 24 in the denominator, which is 4 square root of 6 over negative 23, or negative 4 square root of 6 over 23.